always taught to stay inside the lines, but sooner or later I'll be a traitor to the warning signs.
The first thing I'm going to talk about today is gliding on the ice. The skater is able to glide on the ice once they start moving due to the low friction of the skate blade with the ice. This low friction allows the skater to easily glide over the ice surface. Since the friction of the blade with the ice is almost zero, the skater can propel him or herself forward by pushing off the ice with a force perpendicular to the skate blade.
I was always taught to stay inside the lines, but sooner or later I'll be a traitor.
The next thing I'm going to talk about today is spins. As you can see, she's already generating angular momentum by skating on a curve and pushing with her other leg. Due to the conservation of angular momentum with the equation L equals I omega, where L is angular momentum, I is the moment of inertia, and omega is angular velocity. Since angular momentum stays the same due to the law of conservation of angular momentum, when the moment of inertia gets smaller as the skater moves her arms in, the angular velocity increases. This is why the skater spins faster and faster as she pulls her arms in. Torque is a rotational force. In fact, the word itself comes from the Latin for to twist. In a sense, torque causes rotation about an axis. The definition is the product of the distance from the axis of rotation, often called the lever arm, with the force that is perpendicular to the lever arm. A skater, in order to rotate, must exert a force on his or her body by pushing against the ice. In edge spins, the skater pushes one foot against the ice to start the turn. You also see this in multiple rotation edge jumps. In these jumps, the skater takes off from the ice, turning the skate as he or she does so, which causes torque. The difference between dancing on a floor and skating on ice is the lack of friction. So what is friction exactly? It is a force that resists when two objects slide against each other, dissipating their energy of motion. Friction arises because the molecules on both surfaces bond with each other and resist when the surfaces try to move away and break the bonds. The more rough and jagged something is, the more easily more of its molecules will come in contact with the molecules on the surface it touches.